Hi everyone. So today we'll continue with prism. And so these are the questions they can ask um in prisms. It could be what are prisms, the optics of prisms, what are the rotations of prisms and the use of prisms in ophthalmology. However, the other part of the prisms I will be talking about that they are commonly asked in MCQ. So, as a form of introduction, so prisms are portion of the refractive medium that has two plane surface at incline at an angle. So they're like refractive medium. So that's the name. That means they can bend light. The meaning of refraction I'll talk about. So bending of light. So the prisms that can bend light and they have two plane surfaces are inclined at an angle. So the meaning is that they have these two plane surface like this. I see this first plane, the second plane, and these two surfaces are inclined at an angle. So this is the angle at by which they are inclined. And this angle is called the apical angle or the refracting angle. And so the first diagram to draw in the optics of prism after defining is the representation of the prism itself. And so the shortcuts to make it easy to draw that I draw two triangle like this, the um oblique kind of. In this way, it makes it easy to draw. Okay, so I put another one there. Is to make sure that you are drawing the top of these two is at the same level, and this one is at the same level, so that you can join it together. Yes, this is the prisms. This is the diagram representing the prism. And so the line bisecting the angle, the plane surface, I mean, it's called the axis, or it's bisecting the angle too, actually. Bisect the angle, and of course, separate the plane surface. So line bisecting the angle, the apical angle that we mentioned, which is the angle at the apex, is the apical angle of the flattened angle. And the line cutting across the angle into two, it's called the axis of the prism. This line is the axis of the prism. And then opposite that axis is the base. So this is the base of the prism. Then this is the axis line bisecting the angle into two. So that's the diagram of the prism to draw. The next thing to talk about the way the prisms are rated um, based on their base because the rotation is based on the base. So you can have this out, you can have this in, you can have this up, or based down prism. So after that, part of the optics is also to talk about the deviations because the purpose of the prism is to deviate light. So let's talk about how it does that. So um, these are prism. Yeah, and so just put your angle, replica angle, and then inquiries are coming from there, and then just put query. So this is the recast in optics. Once you do not put any medium, it's assumed that this surrounding medium of the prisms, they are here. So they are here, and then this prism, of course, is glass. So it's moving from a less dense to a less from here to glass prism. So I'm moving from a less dense to a denser medium. So you can see my number. So you can see the incidence angle here, and this is the incident rate. This is the incident rate. Incident rate. Okay, so yeah, and then that's the incident angle. Okay, angle of incidence. So it's moving from a less dense to a denser middle, it's going to move toward normal because again, from a less dense, less thick to its middle, it's going to move toward normal. So it's going to move toward normal. And of course, it puts on normal here again, right? It's going to move away from the normal. Now it's moving from a denser to a less dense, it's going to move away from the normal, away from the normal. Now see that what we used to talk about that, oh, prisms, the rays are actually deviated toward the base. This is the meaning. The lights are deviated toward the base. The lights that are coming are deviated toward the base. So this is the emergent ray. So the prism will bend line toward the base. That's probably the reason why the weight is based on the base. The emergent ray. So you put the angle, emergent angle. Now, the totality of deviation, what determines is that with the extent the rays that are coming here, the extent is make it broken. I will make my own broken by training part. So just make it broken. That time the amount of deviation. You can now see that the deviation is actually dependent on these two rays. Because if there was no prism, this was how it will have continued going like that. Can you see? But because of the prism, it bent it toward the base. It was bending until eventually come out. And so that's the amount of deviation we're talking about. This is deviation. That's the deviation now we're talking about. Deviation, how much this prism can deviate. So that's the deviation we should talk about in prism. And so you can also label the other part, the angle of incidence. Okay, you know that, and then fatten out, then you put it. So that's the deviation we are talking about. That's occurring in the prism. Sorry. All right. So now this deviation, what factor does it depend on? How can come out in F2? To get the deviation, that deviation is affected by three things. The AIR, that's the models used to use. AIR. The A is the apical angle or the refracting angle. The apical angle or the refracting angle. I is the incidence angle. And the R is the refractive index of material for which the prism is made of. So refractive index of material. So these are the things that affect the amount of deviation. So the refractive index of the material or which the prism is made up of. So that's the how. So this thing are the thing that affects deviation. Now, there's something called symmetrical refraction. So which you can mention as part of the optics too. We used to say that the fraction is said to be symmetrical when the angle of incidence is equal to the angle of emergence. So when we have this angle, we call it this. Like this one is almost very equal. So you can actually say the fraction is symmetrical. When the angle of incidence is equal to the angle of emergence, the fraction is said to be symmetrical. And the deviation at that particular point is called the angle of minimum deviation. So that means the deviation is least, is minimal. When the angle of incidence is equal to the angle of convergence, and that point, the refraction is said to be symmetrical. So this is the meaning of symmetrical refraction. So we are talking about that. That means refraction at both ends at the two plane surface is symmetrical, is equal. That's why the incident angle will be equal to the convergence angle. And that deviation that now occur, which totaling the two together as we draw here, is deviation, is angle of deviation. And so for a glass prism, the angle of deviation is given by the formula D is equals to n minus 1 times alpha. So the n is the refractive index. So for the glass now, the refractive index is 1.5, that's 1.5 minus 1 times alpha. And that is 0.5 times alpha. Alpha is what refracting angle it can. That's like half. 0.5 is what half now, half. And that's why it now says half over 2. The division for a glass prism is half over 2. This is very important in the clinical activities. So division is half over 2. So division is like a refracting angle by 2. So now, what is the importance of this? Okay, let's use a fresh to talk about the importance of this. We want to do squint assessments. Okay, you have a child or adult with squints, and they want to check the squints, and then you put the HPAC test, and then you continue like that. So let's start from the how we do it first. Normally there are different positions people can be in the patient that has squints. So because I want you to understand the clinical importance of that derivation because you have very the half of the fatting angle. So this is the pupil. So if there are different positions, the corner first can be your HPAC test that you assign the patient at different position can be. It can be on the center, that would be perfect. Or it can be just between the center and the pupillar margin, or it can be at the pupillar margin, or it can be at the mid iris. You get so mid iris, or it can be at the numbers, and of course greater than numbers. And as you know, the between the pupillar margin and the mid pupil, kind of like between the center of the pupil and the pupillar margin is 7 degrees. That's 7 degrees. And on the pupillar margin is 15 degrees. Okay, that's your visual go. And the stroma is 30, mid iris is 30 degrees. I mean, and then this is 45 degrees. And once it's greater than the limbus, it's greater than 45 degrees. Now, I know we notice. Normally we have said that, oh, this is actually let us maybe put your HBAC. Then you put it, you said that oh, this 15-degree ET by HBAC. Now to be objectively sure of the amount of deviation you get, you now multiply by 2. I'm sure that's what we should do. So we just multiply the 15-degree and then multiply it by 2 to give you the prism diopter. That will determine the lens you pick from the lens rack, from the prism rack, the prism you are going to pick. If you start degree, you are going to multiply by 2 too. You ever wonder why we are multiplying by 2? We are multiplying by 2 because of that deviation. We know that deviation, which I said earlier, is half of the refracting angle. And so the HBAC we are doing is deviation. So if you have like 15-degree deviation by the HBAC, that means the refracting angle is going to be what? That will be alpha divided by 2, and that will be what? 2 times 15. And that's why the refracting angle will now be equal to 30 degrees. And the refracting angle, when you get the notation of prism, it's simpler than the prism diopter in class prism. So by the time we get the notation, we understand why the refracting angle is not as prism diopter. But this is telling you that what you are doing by HPAC is actually the derivation. ET, XT, whatever, hypophoria, hyperphoria, or hypophoria, or hypotropia, you're measuring it, you get so, and then you put your HPAC. That HPAC is derivation. when we multiply it by 2, so that will give you the refracting angle, which is 30 degrees. And that refracting angle is the same thing as the prism delta. By the time we get to the machine, we understand why it's the same thing. So, and that's the clinical importance of that derivation I'm talking about. So it's important squeeze assessment to be able to pick and then estimate the gas prism limit. So because of that, that's why we multiply by 2. So the next topic talk about the need function by prism and then we move from there. Thank you.